Hello, today we are going to present you guys on how to synthesize paracetamol from phenol. IUPAC name for paracetamol is N,4-hydrophenyl ethanamide, and this is the molecular structure. Phenol has to undergo many reactions to convert it to paracetamol. First of all, phenol has to be nitrated using nitric acid to form nitrophenol with two isomers, which is para-nitrophenol and ortho-nitrophenol, which has to be separated. Para-nitrophenol will then has to undergo reduction with sodium borohydride to produce para-aminophenol. This key ingredient will then be treated with acetic anhydride to form paracetamol. The first step is to dilute 40 ml of concentrated nitric acid in 80 ml water in a conical flask. Meanwhile, 40 grams of phenol is dissolved in 20 ml of water. The phenol is then transferred into a burette. Burette is placed on top of the flask. Thermometer is also added to the system to keep an eye on the temperature. The temperature is kept at 40 degrees Celsius to give major yield of para-nitrophenol isomers. This is because para-nitrophenol is more stable to form at higher temperature due to its stirring effect. The phenol is then drop by drop from the burette into the flask while swirling. A very dark oily mixture will form and the reaction is exothermic.
After all the phenol is added, it is left to cool to room temperature. The reaction mixture is transferred into the separatory funnel. Two layers of oily mixture is observed. The separation of the two dark layers may be hard to distinguish, so must be proceeded with caution. The bottom layer of the oily mixture which contains the nitrophenol is separated by draining it into another beaker. The nitrophenols obtained contains isomer para-nitrophenol and ortho-nitrophenol and also impurities. The one that we really need to synthesize the paracetamol is only para-nitrophenol. Ortho-nitrophenol is separated from the mixture by distillation as ortho-nitrophenol has lower boiling point than para-nitrophenol. Para-nitrophenol has higher boiling point due to its stability but its stirring effect. The mixture is set up for a simple distillation. Ortho-nitrophenol will be collected in the distilling flask which is yellow in color. Do note that ortho-nitrophenol might clog the distilling tube, so it must be cleared from time to time. Then remaining fluid residue contain para-nitrophenol and impurities, therefore needed to be separated. The volume of mixture is adjusted to 200 ml and 2 grams of acetylene charcoal is added. The mixture is reheated to the boiling for 1 minute. The para-nitrophenol is now dissolved in the mixture and the impurities will adhere to the activated charcoal. A hot filtration is quickly done with a coarse flattened with the paper. The obtained filtrate will allow to cool and light yellow-colored para-nitrophenol will crystallize. They will be collected and left to dry.
So the next part is the reduction of para-nitrophenol. So this step is to reduce para-nitrophenol to para-aminophenol, which is the main ingredient to synthesize the paracetamol. First of all, 75 grams of sodium hydroxide is diluted in 80 ml of water in a flask. Then, 3 spatula of sodium borohydride is added. 90 mg of 5% of palladium on carbon is added. So the palladium is acting as a catalyst. Then, the mixture is put in an ice bath, which is temperature is kept between 13 to 17 degrees Celsius for optimum condition for reaction. So this is a catalytic reduction with sodium borohydride. So because the reaction is exothermic, para-nitrophenol is then added part by part, so there will be no drastic increment in the temperature. During this phase, para-nitrophenol is being reduced to para-aminophenol by hydrogen gas produced by sodium borohydride.
After all the p-nitrophenol is added, 20 ml of 2 molar hydrochloric acid is added to decompose the sodium borohydride in the solution. This reaction will produce boric acid, sodium chloride salt, and liberate hydrogen gas, therefore will cause bubbling, as you can see here. Hydrochloric acid will be added until bubbling is no longer observed, showing that all the sodium borohydride is gone. P-aminophenol is weak base and will react with the acid to form chloride salt, which is soluble. After that, the mixture is then filtered to remove all the carbon. And then, the solution might turn purple because of the decomposition of aminophenol due to the presence of light in the surrounding. The mixture is then added with the sodium bicarbonate, which will release carbon dioxide. Sodium bicarbonate will be added until it reaches its neutralization point, which will result in a change to the color brown and no more fizzing observed. The p-aminophenol now exists in its free base form. After that, it will then be left to crystallize. The crystallized para-aminophenol are then collected with vacuum filtration, as you can see on the bottom right here, and be dried. The crystallized aminophenol is reddish yellow in color, as you can see in the slide above. Moving on to part 3, where we can calculate the amount of p-aminophenol needed. As we all know, the molecular weight of paracetamol is 151 gram per mole. And then, with the given mass of paracetamol, which is 60 gram, we can find the mole of paracetamol by using the formula of mass of paracetamol divided with the molar mass of paracetamol, which we're gonna get 0.397 mole. So, based on the stoichiometry below, we know that 1 mole of p-aminophenol will produce 1 mole of paracetamol. And then, we have also had to be given that the theoretical yield percentage is 80%, which is the percentage of p-aminophenol to the paracetamol. So, based on the theoretical percentage that we given, we know that when 80% of p-aminophenol, we will gonna get 1 mole of the mole of paracetamol, which we're gonna get 0.8. Why is given that the mole of p-aminophenol equal to the mole of paracetamol, which is 0.397. So, we're gonna get the mole of p-aminophenol is 0.496 mole. After we get the mole of p-aminophenol, we can calculate the mass of p-aminophenol needed based on the formula molar mass times with the mole. So, we know that the molecular weight of p-aminophenol is 109 gram per mole. We can find the mass of p-aminophenol by calculating by times with the mole, by the molar mass of aminophenol times with the mole of p-aminophenol. We're gonna get 54.14 gram, this is the mass of p-aminophenol.
So, for the last part, we are going to synthesize paracetamol from 4-aminophenol. Paracetamol can be prepared by treating the para-aminophenol with acetic anhydride, which will form N4-hydroxyphenyl ethanamide. First step is to add 55 gram of 4-aminophenol that has been weighed and is transferred into a 500 ml of dried conical flask. 60 ml of acetic anhydride is then measured and added to the same flask. The flask is then put in a boiling water bath and continuously stirred. The mixture is then set to warm for about 30 minutes. This is the reaction mechanism, where the 4-aminophenol will react with the acetic anhydride molecule. So the 4-aminophenol has an amine group which has a lone pair. So it will do the nitrogen atom will do a nucleophilic attack on the carbonyl group on the acetic anhydride molecule. Okay, this is the reaction mechanism. The 4-aminophenol molecule has an amine group which has a lone pair. The nitrogen group will do a nucleophilic attack on the carbonyl group on the acetic anhydride molecule, which will form an intermediate molecule which has this carbon-nitrogen bond. And then, after all the changing of the electrons, as the oxygen electrons will be taken away and be separated from its carbon next to it, the intermediate will be separated into 2 separate molecules, which is paracetamol and ethanoic acid. The mixture is then set aside to cool to room temperature before putting it into an ice bath to speed up the crystallization of the paracetamol. The mixture is stirred vigorously and white precipitate, which is the paracetamol, is formed inside the beaker. The unpure crude product obtained is filtered into a Bushnell funnel using suction to be collected. The precipitate is washed with cold water. It is then dried between folds of filter paper and let to dry. To purify the paracetamol obtained, the crude product obtained has to undergo recrystallization. The solvent used here is 50% methanol in water. 50 ml of the methanol in water is put in a conical flask and is heated on a hot plate for about 60 Celsius. All the crude product is put in another separate flask and is heated on the same hot plate. The methanol in water is then pipetted into the crude product to dissolve them. Methanol is added until all the solid is dissolved. The mixture is allowed to cool down a bit before putting it in an ice bath to speed up the crystallization of the paracetamol. The mixture is then filtrated by the vacuum filtration and paracetamol is The mixture is then filtrated by the vacuum filtration and the paracetamol obtained is let to dry in an oven. So, in the end, we will gain 60 gram of paracetamol as we have calculated before. Thank you.